welcome back to yet another video. This is part B of more mathematics questions. Alright, so let's get into it. Alright, so in this question here, it says at the end of any year, a motor vehicle is worth 20% less than what it was worth at the beginning of the year. If a motor vehicle is worth 10 million in December 2020, then its value in January 2020 was. Alright, so for this question, we have to recognize that the value of the car in January would have been more than in December. Alright? And what some students might do is that they find 20% of the 10 million and then them subtract that amount from the 10 million. Alright? And you're going to get a value that's less than 10 million. Alright? So that's a wrong approach. Alright? So this is what you're going to do. And what I'm sharing with you is just one approach of other approaches. Alright? So there are very different ways of answering this question. So since percentage is out of 100, right? And it's less than, what we're going to do is that we're going to subtract 20 from 100. Alright, so everything is out of 100%, and we're going to subtract 20 from that, and that will give us 80%. Alright, so that's the first step. Now normally we know that 80% as a fraction is 80 over 100. Alright, but it's because we want to find the price before it was depreciated or discounted, so to speak. What we're going to do is that we're going to invert this multiplication factor here. So we're not going to have 80 over 100. We're going to have 100 over 80. Alright? And then now we're going to multiply this now by the 10 million. Alright? So we're going to have 100 over 80 times 10 million. Alright? And when you simplify that, we're going to end up with 12.5. Let me write that a little better. $12.5 million. Alright? So I'm giving you a little bit of work. Just reduce that fraction there, and you're going to get 12.5 million. As you can see, this is actually more than a 10 million. Alright? And if you were to find 20% of 12.5 million and then subtract whatever you get from the 12.5 million, you're going to end up with $10 million. Alright? Okay, so that's how you approach that question. Alright, so we're going to move on to the next question. So here is another car question. So it says a businessman bought an SUV for 12 million. The SUV depreciates by 20% in the first year and 10% in each of the following years. Alright? So the value of the SUV at the end of the second year was, so basically in the first year you go down by 20%. Alright, second year you go down by what? 10%, and the following years it go down by 10% and 10%. Alright, and these are the things that insurance company use to value your car and give you an insurance figure for your vehicle. Likewise, it's a bit different with house and land. It's a bit different. All right. So what we're going to do, we're going to find 20% of the 12 million. All right, and whatever we get, we subtract that amount from the 12 million, and then we find 10% of whatever we get from that amount, and so forth, so on. All right. Let me tell you what you should not do. Don't find 30% of 12 million and then subtract that amount from the 12 million to get an answer. All right, it doesn't work like that. All right, so what we're going to do, we're going to find 20%, or even better, rather than finding 20%, let's just find 80% of 12 million. Since everything is out of 100 and it's been reduced by 20, we just say 20 from 100, which is what? 80. So we just find 80% of $12 million. All right, so we're gonna find 80% of $12 million. All right, and when you do that computation, you get $9.6 million. All right. By the way, 9.6 million is written like this: 9, 6. All right, so that's $9.6 million. So let me just erase that little thing there. All right, then now we're gonna find 90%. So because it's 10%, we just subtract 10 from 100, which is 90. All right, so we're gonna find 90%. Oh boy, this thing we're not. Sorry about that, guys. Right, so we're gonna find 90% of $9.6 million. All right, and when you work it out now, you're gonna get $8 million $640,000. So that's our answer. So at the end of 2 years, the car would have been valued at $8,640,000. Boy, that's a lot of money that comes out of a car, too. You bought it for 12 million and gone up to 8. Boy. So it is what it is. Alright, so we're going to move on to the next question. Alright, so we're going from car to house now. Yeah, man. The mathematics is about teaching you how to reason out questions that are real and applicable. Alright? So when you go out there in the world, you can reason out for your own side and make your own decisions and, you know, make you a better person when you're mathematically inclined. Alright, so this question talking about is saying that the annual interest rate on a 25-year mortgage on a house assessed at a value of $250,000 is 10 cents on every $1. What is interest paid on the mortgage for the first year? Alright, so let us get this out of the way. You know, I've posed this question to some students, and a student was saying that, sir, are you going to use a simple interest formula? Well, because the word simple is not in the question, we're not going to use the formula. Alright? So even when it says the annual interest, you know, because it didn't specify, it's simple interest, we can't use simple interest formula. Alright? So that's that. Alright, so I guess one of the most valuable part of this question is this statement here. It says 10 cents. So the interest is actually 10 cents on every $1. Alright? So that's what we're gonna figure out. Alright, so first of all, them said 10 cents. 10 cents on every $1, or 10 cents of $1. That's how they define the interest rate. No, we can't compare cents and dollars. We need to compare dollars with dollars or cents with cents. Let's compare dollars with dollars. So 10 cents is actually $0.1. Alright? And $0.1 of $1 is actually $0.1. Alright? In other words, every $1 out of every single $1, they're gonna take out $0.1 out of every dollar. Alright? Then now you say, alright, how much $1 in $250,000? Well, it's a dollar, right? So you have $250,000 $1 in $250,000. Alright? So what we're going to do now is that we're going to multiply the interest rate, which is 0.1, times 250,000. Because you have $250,000 $1 in the house. Alright? And when you work with that, you end up with $25,000. US. Alright, so that's the interest rate in the first year if you're going to take out a 25-year mortgage. Alright, so that's that. Let's move on to the next question. Alright, so this is matrices. Alright, now as you can see, well, these are called equal matrices, and we have a scalar multiplied by a matrix. Scalar is 6 and 5. Alright, so what we're going to do, oops, sorry about that. Where are we? Alright, so first of all, we're going to say 6 times x. 6 times x is 6x equal 5 times 12, which is what? 60. And we're going to reduce that by dividing everything by 6. So x is equal to 10. And for the y, well, it's 6y. So 6 times y is 6y. And 5, 6 is 30. So we divide everything by 6. So y is equal to 5. Nice little question. Alright. Let's move on or drive on. Alright, so right, this is probably life that most persons you know, have a pitch turn right now. Sum on everything. Alright. Okay, so we have two matrix. Oh, some numbers are missing in matrix N. Let me just jot those in. Oops. Sorry about that. So this should be 3. Let me use another color. Alright, so this would be 3 and 0. Alright, so the question says, what is the determinant? What is the determinant of matrix M? Alright, now M is a 2 by 2 matrix, meaning it has 2 rows and 2 columns, and we call that the order of the matrix or the dimension of the matrix. Alright, and to find the determinant of a 2 by 2 matrix, what do we multiply? Alright, so we're going to multiply the leading diagonal, which is -4 and 3. And then we're gonna subtract the other diagonal. Alright, so basically we're gonna have -4 times 3 subtract -2 times 6. That's going to give us -12. These two negatives give us a positive. 2 sixes is 12. Alright, and negative 12 plus 12 is actually what? 0. So the determinant of this matrix here is 0. Alright, and we have a special name for the matrix itself when you have a determinant of equal to 0. So we say that matrix is called a singular matrix. If it's not equal to 0, it's called a non-singular matrix. Alright, so that's the first part of the question. Let's look at the second part now. It says, what is the order of matrix n? Alright, the order means is just stating the row, the number of rows times the number of columns. So we have row 1, row 2, and row 3. So we have 3 rows, and then now we have column 1, column 2, column 3, column 4. Alright, so we have 3 rows and we have 4 columns. And this is how we write it, like that. So the first number tells you the number of rows, and the second number tells you the number of columns. Alright, so we're going to move on to the next question. Okay, it says the equation of the line which passes through the point -3 and 1 has a gradient of 2/3 is. So basically, we want to find the equation of this line, and we're given the gradient, and we're also given a point. Alright, so to answer this question, we're going to use the format y equals mx plus c to answer this question. Alright, so all straight line have this form here: y equals mx plus c. Alright, where x and y are variables, m represents the gradient and c represents the y-intercept. Alright, so what we're going to do now, we're going to put in all these values. So this would have been the x value, alright, and the 1 would have been the y value, and the m would have been equal to what? 2/3. So the only thing we don't know there is what? Is c. So we're going to put in x, y, and m, and we're going to find c. So that's the first approach. So let me write about this. Y is equal to mx plus c. Alright, so y is 1 from this. M is 2/3. Mx, m times x, so it's 2/3 times -3. Let's put a 1 there. Plus c. Let us reduce this fraction here. As you can see, these 2 3's will cancel out. Alright, and what remains is 1 equal, well, this turns out to be just -2 plus c. So I'm going to add plus 2 on the left and also on the right. So 1 plus 2, that's -2 plus 2 plus c. That will go away. Therefore, c is equal to what? 3. Alright? So we're not finished, because we need to write the answer now too. So the answer is let's see if I can get some space over here. I'm actually writing on clouds. Can you believe that? Alright. Alright, so the answer is, what to do, we write about the y, we put him at the m, is 2/3, grab the x, and we'll drop in our c. C is plus 3. So this is our answer. Alright, so we're going to move on to the next question. Alright, so what's happening right here is that we have a straight line, right? We have a straight line and we have these points, and we want to figure out if any of these points actually are on the straight line. Alright, so to do this is that we're going to use this equation. Alright, let us try A. Let us test to see if A is actually on that line. Let me show you how to do this. So what we do, we're going to replace x and y in this equation with 2 and 3. Alright, so we're going to have 3 equal to multiply by x. What is x? 2 subtract 3. So we have 3 equal, well, 2 2s is 4, and 3 from 4 is what? 1. Alright, now is the statement a true statement? Is 3 equal to 1? No. 3 can't be equal to 1. 3 must be equal to 3, or 1 must be equal to 1. So what this is saying is that this point does not lie on this straight line here. Alright? Alright, so we're going to go to C, which is the correct answer. Let's try C now. So we have C, we're going to have negative 3. Because remember, we're using this, right? So we have y here. And the y value corresponding to this point is what? Negative 3. We have negative 3 equals 2, which is this 2, multiply by x. What is x? 0. Then we have what? Subtract, oops, right here, subtract 3. Now 2 times 0 is 0. So end up with negative 3 equal negative 3. Alright, so negative 3 is actually equal to negative 3. So therefore C actually lies on this line here. Alright, so we're going to move on to the next question. Alright, so this question here looks a bit complicated, looks pretty long, but it's not that complicated. Alright, so it says the table below shows a two-way table which shows the preferred type of chicken ordered at a fast food joint on a particular day for a group of 200 customers. Alright, so let's look at the table. Alright, so as you can see, we have type of chicken. We have 3 types. Alright, and we have female and we have male. Alright, so basically, it says we have a two-way table. Alright, so it's like the values go across like that, and the values come down like that. So in other words, we're computing, male and female. It's like we're computing 2 variables. All right, male and female go across, and types of chicken, male and female, coming down. All right. So we have females. So the 108 would represent the total number of females who pass through the fast food joint on that particular day. And the 92 would represent the total number of males that would have passed through the fast food And when you add 108 and then 92, you get 200. So if you come along here now, what they're saying that 50 female and 32 male purchase spicy chicken, and the total would have been 66. All right, so on that particular day, 66 customers out of the 200 would have purchased spicy. All right, likewise barbecue, likewise the original. All right, and if you're to add up all these values here, you still get 200. All right, so and that's what a two-way table is. All right, so let's answer the question now. But before we can answer the question, you see, I want you guys to understand what probability means. So in its simplest way. Because what is the probability? Now your probability, you see, is what you want. Is what you want. Or in other words, your favorable outcome divided by your total possible outcome. Alright, so for example, you're doing 10 CXCs, right? I mean, your total outcome would have been 10 because you're sitting 10 CXCs. Alright, and let's say your favorable outcome. Suppose you want all of them. That's 10 out of 10. So the probability would have been what? 1. Alright? Yeah. Suppose you're not sure. Alright? You're not sure. I said, boy, maybe we get 7 out of the 10. So the probability is 0.7. So the 7 represents your favorable outcome. Alright, and the 10 represents the total number of CXCs that you're taking. Alright, and that's probability defined in simplest terms. But let's get to the question. This is a female. So notice they're talking about what? A female. A female customer is picked at random from the group. What is the probability that she does not order barbecue chicken on that day? Alright, so for the females, remember, probability is your favorable outcome divided by total possible outcome. Alright, let's look at the total possible outcome. So we're talking about females. So is it 108 or is it 200? A reasonable question. No, it is 200. Let me tell you why. It says a female customer is picked at random from the group. No, they didn't say the group of female customers. Well, in fair now, I mean, you're talking about female customers, but it says picked at random from the group. And if you look up here, so it says for a group of 200 customers. So they're talking about the entire customers that pass through the food joint. Alright? If that said that a female customer is picked at random from the group of female, alright, then it would have been out of 108. Alright? But the word group is a general statement. Alright, so let's move on now. The favorable outcome now, the numerator part now. So it says probability that she does not order barbecue. So she did not order barbecue. Now if she didn't order barbecue, she must have to order spicy or what? The original. Alright? It should have been 50 and 30. Now 50 plus 30 would have been 80. Alright, so we're not sure if it's spicy only or original only. Alright? So all we know is about she didn't order barbecue. So if she didn't order barbecue, It's either spicy or original, which is 50 plus 30. And when we reduce this, we will get 2 over 5. Alright, so those 2 zeros go away. 2 into 8 goes 4. 2 into 20 goes 10. 2 into 4 goes 2. 2 into 10 goes 5. So the probability would have been 2 over 5. Alright, let's move on to the next question. Alright, so the sum of two positive numbers, P and Q, is 32. Their difference is 12. What is the smaller number? Alright, so this is actually a simultaneous equation question in disguise. So the sum of two positive numbers, so P plus Q equals what? 32. That's the sum. Their difference is 12. Alright? What is a smaller number? So what we're going to do, we're going to add these two equations. Equation 1, equation 2. Why are we adding? Because when added two equations, the negative Q and the positive Q will disappear. Ended up with us what? P plus P, which is what? 2P. So 2P is equal to 44. Divide everything by 2. Hence, P is equal to 22. So we're going to find Q now because we don't know them smaller by choosing one of these equations. So let's choose equation 1 and we're going to substitute P equal 22 in equation 1. So we end up with 22 plus Q equals 32. We're going to subtract 22 from both sides. So Q is equal to 32. Subtract 22. So Q, let me write the Q careful. We look at 9. Q is equal to 10. So this would have been the what? The smaller value or smaller number. Alright. So moving on smoothly. Alright, so here we have a trigonometry question. Okay, so well, first of all, it's a right angle triangle. So we're going to use the trig ratios, so, sine, cos, and tan. And the acronym, so-called TOA. Alright, so it's sine, so it's so, right? Alright, so alright, so we're going to use, well, it is already sine, right? Alright, so let's label our triangle. So this would have been the reference angle. This is the longest side, the hypotenuse, because it's opposite the right angle. If this is reference angle, remember the side that's between the right angle and the reference angle is called the adjacent side. Alright, so if this is the adjacent and that's hypotenuse, then this must have been the opposite. Alright, so we want sine. So sine of an angle, let's call it theta, is opposite, which is 5, divided by the hypotenuse, which we don't know. Alright? So if you can recall the Pythagorean triples, All right, we have 5, 12, and 13. All right, so the hypotenuse is actually 13. All right, or we can just use Pythagoras, theorem the long way. Because you'll have to be able to recognize that this is a Pythagorean triple. All right, so let's say you didn't know the triples. So basically, the 12 and the 5 would have been two short sides, and this is the formula. When you have two short sides, you just square and add the two short sides. If it is a short side you want to find, we subtract. So that's 169, and the root of 169 is 13. So anytime we want to find a long side, we add. And we want to find a short side, we subtract. Alright, so we're going to move on to the next question. Alright, so what we have here, some values for this question, they were omitted. Let me just write in the values here. So this would have been 6, this would have been 7, and that's 3. Let's answer the first part of the question. The diagram above refers to the following pair of what? Similar triangles. Alright? Oh, and this is an angle here. So those two angles Alright, so these two angles, they're equal, and these two angles, they're also equal. Alright, so since the triangles are similar, you see, their sides are proportionate. As you can see, side EF is proportionate to BC, meaning if you divide those two numbers, you're gonna get a constant, which is 0.5. Alright, or that's our scale factor then. Alright, so basically how they got the 3 here is that they multiply the 6 times the scale factor. 6 times a half is 3. The question says the length of BF, which is this side here, hypotenuse, the right angle triangle. Alright, so if the scale factor is 0.5 and we want to know what DF is, all we need to do is look at AC, and AC is 7, and multiply 7 times the scale factor. The 7 times 0.5 is 3.5 centimeter, and that's the answer for the first part. Alright, so let's look at the other part of the question. I'm just going to erase what we have here. Alright. Now this question can throw off some students. It can throw off some students. It says the if the area of a triangle is 20 centimeters squared, then what is the area of triangle DEF? Now, you might be saying, boy, sir, it didn't go down by half, so if this is 20, then half of 20 is 10. So the answer is 10. Because everything cut down by 2. Or everything chopped into 2. Alright? But it's not so straightforward when you're dealing with area. Alright? What we're going to do is that we're going to find AB, and AB is the perpendicular height. If you can find AB, let us say AB was say 10. No, let me not use 10. Let us say AB is say 8. If AB was 8, then DE or ED would have been what? 4. Alright? So how we're going to find the perpendicular height? Well, we're going to use the formula. Alright, so for the triangle ABC, area is a half base multiplied by its perpendicular height. So the area is 20 centimeters squared. So 20 is equal to a half. The base is 6. And the perpendicular height, we don't know. We want to find out. Half of 6 is what? 3. So we end up with 3 times h. What is 3 times h? 3h. So therefore 3h is equal to what? 20. So therefore h, which is the height of the first triangle, is equal to 20 over 3. So this is actually what? 20 over 3. Now, if this height AB here is 20 over 3, then this height ED would go down, we're going to times by a half, to get side ED, because the scale factor is what? 0.5. Alright? So the good thing about this video is that you can always pause and look over and see what's happening. Alright, so let me just find my marker. Alright, so we're gonna multiply 20 over 3, which represents the height of AB, times a half. And when we reduce that, 2 can go into 20, 10 times. We end up with what? 10 over 3. So that's the height of ED, 10 over 3. Alright? So now that we have the height, we can find the area of triangle DEF. So the area is actually a half multiplied by the base, which is what? 3, multiplied by the perpendicular height, which is 10 over 3. So looking at this, we recognize that the 3 cancel the 3 and 2 cancel the 10 to give us what? 5 centimeters squared. So we notice it's not 10. The area is actually what? 5 centimeters squared. Alright, hope you guys are following. Alright, this is our last question. Alright, so the following diagram below shows a cumulative frequency polygon or cumulative frequency curve based on the marks of 100 students who sat a calculus examination at college A. Alright, now before I even start this question, let me just explain to you what a cumulative frequency curve is all about. All right. So let us say we have some values, right? We have, well, let's use marks. Let's say we have some marks, some scores done in a test. All right, and we have frequency. Let's start with, say, hypothetical. Let's say 50. All right, let's say 10% got 50, and then we have 60%. All right, let's say 7% got 60%. We have, say, 70. Let's say another 10% got 70%. Now we have another column here called the cumulative frequency column. So to get the cumulative frequency column, this is what we do. So the first row, what we do, right about the same frequency, which is 10. And what we do next is we add a 10 and a 7, which is 17, to get the second cumulative frequency. And to get the third cumulative frequency, we add a 17 and this 10, to give us 27. And so we go on and we continue. Now the last number you get would have been the sum of the total frequency, or sum of the frequency. Alright? And that's what cumulative frequency is all about. And what they do, they plot the marks with the cumulative frequency to get the curve. So that's the backdrop of what cumulative frequency is all about. It's an accumulation of frequencies. Alright, so we have 100 students who sat an exam. So if you look at the graph, alright, on the y-axis we have cumulative frequency. Alright, as you can see, that would represent the total number of students. Alright, so the question says, we have 3 questions here, right? What is the median mark scored by the 100 students? Well, median means middle number, not true. How many students do we have? 100. What's half of 100? 50. Alright? So, what we do, we identify the 50 on the cumulative frequency. We'll take, we look at this line here, or we take a ruler. Where it touches the curve, we'll bring it down and read off that value. Turns out that the median is actually 60%. Alright, so the next part of the question says what is the interquartile range? So we all know that range means the difference between the highest value and the lowest value. So they're talking about what we call the interquartile range. Alright, so you have something called the upper quartile, which is 75% of the frequency, or 3/4 of the frequency. Alright, so 3/4 of 100 is how much? Is 75. So what do you locate 75 with your ruler, and you draw a horizontal line across that meets the curve, and then you read the value there. So the upper quartile, let's call it Q2. So we're focusing on this question here. Q2, upper quartile, is what? 70. And let's call Q1 the lower quartile. Now the lower quartile is actually a quarter. What's the word quartile? Right. So the lower quartile is just a quarter of the total frequency, and a quarter of 100 is how much? 25. You locate 25, and with your ruler, you carry it along the horizontal where it touches the curve. You draw a vertical line down and read out that value. That to me looks like 45. Now it says the interquartile range, which is the difference between the highest and the lowest. So the interquartile range would be 45 from 70, which is 25%. So that's the interquartile range. Alright, so alright guys, so that's the end of the show. Oh, sorry. Just realized that I have another question here. It says, if 60% of the students pass the exam, what was the pass mark? Alright, so this question is a little bit tricky. Alright, so bear with me. So 60% of the students pass the exam. Alright, so what we're going to do, we're going to find 60% of the 100 students, and 60% of 100 is actually 60. Alright, now you might think that this 60 represents the number of students who pass, but that is not so. So because it's a cumulative frequency curve, what we need to do is to subtract the 60 from the 100, and that will give us what? 40. Alright, so in other words, 40 students actually passed the test. Alright, so what we do know is that we locate the 40, and we read it off, we draw a line across like that, and we bring it down. It looks to me like 55, 54, 55. So let's call it 54. Alright, so the pass mark is actually approximately, let me use that word, 54% or thereabouts. Alright guys, so this is the end of the show. So thanks for watching. All the best in exams. And this is actually my last video for the academic year. And I hope you find these videos useful in your pursuit for greatness and success in your examinations. Alright, so keep safe, take it easy. God bless.